All right, so we saw at the end of the last video that I was talking about how this data shows a positive relationship, namely that higher values for money for a country and higher values on their test scores are will go hand in hand. Let's put it that way. Um, we'll often say, higher money leads to higher scores, but we want to be careful about that because higher money isn't what causes higher scores. If that was the case, Qatar would be impossible. It's not a cause and effect. It's just that there are um, things that are going on together here, and that money and higher scores tend to go together. But it doesn't mean that one thing is causing the other necessarily. All right, so that leads to types of relationships because what we're talking about there is this kind of relationship. It's positive and it's linear. As X increases, Y increases. As the money increases in a country, the math scores tend to increase in a country, if that makes sense. Okay. That's called a positive linear relationship. I'll also sometimes call it a direct relationship, right? You learned it in algebra classes, sort of like directly proportional, right? The other one that we're really interested in is negative linear relationships, which is as the x increases, the y goes down. So, for example, as money in a country increases, birth rates or birth mortalities, babies dying at birth, tends to go down. Wealthier countries tend to have very few problems with women and mothers and babies dying in during labor, whereas poorer countries have big problems with that. Okay, that's called an inverse relationship. Right? These two in particular are what we're really focusing on for chapter 4. There are some other relationships we want to watch out for, though. There are some non-linear relationships. So very strong relationships, but they don't form a line. There's the quadratic relationship, parabola shaped. It can go up and go back down, or it can be reversed, where it goes down and comes back up. That's the other kind, right? Or there's the exponential relationship. And there's several ones of these, but they form sort of an arch, a curve like this, right? You can have it go down like this, you can have it go up. And then there's when there's no relationship at all. So to be clear, these two, they have very strong relations. They're just not linear. And of course, linear is what we're going to be concerned with through all of chapter 4. These have relations that aren't linear. These have no relation whatsoever. This guy right here, think of something like height for adults and IQ for adults, right? Tall or short doesn't make you smart. Okay. Non-linear relationships and no relationships are kind of different things. But so you have to keep them straight in your mind. These ones have relationships that are not linear. This has just no relation whatsoever. Okay, let's look at exponentials just a little bit more because a lot of things follow exponential curves, especially in real life. So this is the following graph shows the income per person and life expectancy. And you can get these on gapminder.org. I can show you how to do it some other time. What kind of relationship does this appear to have? So when you look at it, see the arch to it? It's not a parabola arch, it's like a curved arch. So this is definitely exponential. The points curve, form a curve, but not a parabola. Parabola is the U shape, the kind of when it goes up and goes back down. Okay. All right, here's that exact same data. See it? This is the same data set. I'm not lying, right? What's changed? So you look at the two of them, you're thinking, what in the world? But look down here. See that? See how it says log? Look up here, linear. So when you look at linear scale, it goes up by the same amount every time. 10,000, 20,000, 30,000, 40,000. See that? Right? Every inch is, well, it's about an inch on my screen, is about 10,000. Down here, it's not doing that. It goes up 1,000, 2,000, 4,000. You're multiplying. What's really happening here is an inch is basically double. So there's 400. About an inch away is about 800. About an inch away is 1,600. 3,200, that's why that line's right there, 3,200. Then 6,400 is right in there, right? And then 12,000 and so on, right? And they just change the scale along the way to show different numbers that are easier to look at, like 10,000.